We'll start with just working with percentages. How do you convert? So there's a little note here. How do you convert anything into a percentage? So percentage means divided by 100, percent. Okay? Does anybody know how to do a fraction into a percentage? Very good. So this one is going to be the top number. I'm going to write this out. Normally you would just do it, right? Divided by the bottom number, and then multiply by 100, and that gives you the percentage. If I just do the division, it doesn't give me a percentage. It gives me a decimal. And then when I multiply by 100, that will turn it into a proper percentage. Okay, so let me get a smaller calculator here. Oh, it's too big. So this one is 25 divided by 32. So this gives me the decimal. But then when I multiply it by 100, and depending on what you're rounding to, this looks like 71% or 71.4%. When you are doing percents, you need to use the percentage symbol, because 71 is not the same as 0.71. But 71% is the same as 0.71. Those two things mean the same thing. So when you use this symbol, you're, in other words, saying I took a decimal and multiplied by 100. So what would I do if I took a decimal like this? Sammy? How? Oh, you got a different answer from me? 25 divided by 32 times 100. 78. Okay, good enough. 0.1. How would I do B? So B is already a decimal. Yeah, very good. So I just take that number, 3.67, and I multiply by 100. And that's going to give me the percentage. So this gives me 367%. And that may seem weird in some circumstances, but there's no reason why you can't have a percentage over 100. The number 1 means 100%. So if this is the number 3, it makes sense that it's more than 100. Okay, good. Find each amount. 40% of 180. Now, what's useful trick here is in mathematics, the word of means multiply or multiplication. So we take 40, turn it back into a proper number, a decimal. How are we going to do that? To get a percentage, we multiply by 100. To use a percentage, we divide by 100. So 40% of 80 is 40 divided by 100 times 80. So the of became a time symbol. And if you can remember that, no matter what the question is asking, you should be able to figure out what it means. And I got 32. That's not a percentage, that's just a number. So 32 out of 80 would be 40%. Nice way to think about these fractions is if it were a test. If this were a test and you got 32 out of 80, you would have got 40% on the test. Okay, 0.3% of 350, same thing. Some people think, oh, it's already a decimal. I'm going to show an extra step for this one. 0.3 divided by 100 is 0.003. So it's already a decimal, but it's got a percentage symbol, so you still divide by 100, and it gives you a really small decimal, extra zeros. And then when I multiply that, I get, that doesn't look right, 0.0, but it might be actually. Yep, I get 1.05. So notice that 0.3 is 30%. 0.003 is 0.3%. This is the mistake some people make. 0.3 is not the same as 0.3%. Okay, so be aware of that. Stop me if there's any questions. We'll keep going. 15 is 75% of what number? Ooh, this is a trickier one. How are we going to do this one? Well, okay, but how'd you do it?
I divided, since 15 is 75% or 25%, so just divided both numbers by 3.
Okay, but what if it was not friendly numbers and you had to actually have a formula or something? How would we do this? I would set up a little equation. Okay? So when we did this, we had 40% divided by 100 times 80. But 80 is the answer that I'm looking for. So it's giving us the answer. It's saying 15, whoops, I want green. 15 is 75% of some number. So I'm going to pick a variable a for that. So how do I solve this? Harmony? Would I multiply though? You're on the right track. Divide? Why would I divide? Look at what this is. Isn't it just an equation where I do divide by 0.75 and divide by 0.75? You know what I mean? Like if we have 3x equals 9, you divide both sides by 3. It's the same thing. So when I was doing these ones, finding a percentage of a number, I multiplied. If you're asked these ones 50%, this probably won't be on EQAO, but 15% is 75 of what number? You end up dividing. Kind of makes sense that it does the opposite. And when you do this, you can check Caleb's thinking that sure enough, it works out to 20. I'm going to skip B for now. You can try that one on your own. It's the same idea. So here's a question using percentages. You're going to buy a $350 netbook, but you're getting a student discount of 15%. How much is the discount or Chromebook or something like that, right? And the final price after taxes. So this one's going to have a whole bunch of parts to it. First of all, I have to figure out the discount. So I'm going to write this down. Is 15% of $350. We just learned how to do that. So do it. I got 5250. What does that mean? This is where you have to think about what's happening in real life. The Chromebook or netbook or whatever was $350, but it's discounted by $52.50. So what do I do? You take that off of the price. What if it was like for some reason increasing in 15% because it's a newer model and is going up? Then you'd be adding it. But in this case, we're going to subtract. So the new price will equal 350 plus 5250 minus, sorry, right. So that should be 297.50. And then it says taxes. Again, they won't ask this on EQAO because taxes are like different depending on the province you're in, and they change year to year. So I don't think, if they did, they would probably give you taxes. Taxes in Ontario now are 13%, which is made up of two different parts. So now I would go ahead and I would find taxes. Leave a bit of a space. And taxes will equal 13% of the new price, which is 13 over 100 times 297.50. And if I round that, I get 38.68. And what do I do with that? Brandon? You add it. So the discount we subtracted, the taxes we added. That's very intuitive to some people, but there's some people that struggle with that a little bit. So the total price is the 27.50 plus 38.68. Any questions? Okay. Proportions. So a proportion is just a special type of equation. Solving them hopefully is something that's easy, that you have done before, and we've even done in this course. So hopefully it's familiar. There's a couple of different strategies that you can use to solve them. So we're going to talk about that when we do a few examples. It's using them, setting them up and using them to solve problems that we're most interested in. So how do you set them up? So we're going to solve a few. I might leave a few for you to solve, and then we're going to get to using them momentarily. How would I solve the first one?
You take the part of the equation that you have a number on each side of the equal sign and divide them.
Okay.
And then you take the numerator, whichever one you have, and then either divide or multiply the number. That's the square root.
Okay, no, I think you're right. Anybody else want to add to that? Or have another idea of how they do it? There is a trick that some people use where I take whatever's on the bottom of one side and multiply on the other side. And when I take the 10 and I multiply over there, and I take the 2, oops, way too thick. I take the 2 and multiply over there. And this will work, so let's try it. So I take 10 and multiply by x, and I get 10x. And I get 2 times 15, which is 30. And now what do? Divide by 10. It's just an equation on both sides, and x is 3. So, but I think it's a little bit weird to take the 10 over here and multiply it and then bring it back over here and divide it. Why did I move it if I was just moving it back? So that was kind of a waste of our time. But there's another case where this is a useful trick to use. And it does work, it's just extra work. So really all you did is you took both of these and multiplied them by 2. Multiplied by 2 on both sides. That got rid of the 2 there. And x was 15 times 2 divided by 10. Which gave us 3. Okay? Does that make sense? Try the next one. Who's got this one? Ben? Did you do it?
Yeah.
What'd you get?
Y is 12.
12. 3 times 28 divided by 7 gives you 12. Good. So 17 times 6 is 102. Whoops. So A is 102 over 23. And depending on what you're doing, you might leave it as a fraction, or you might round it to 4.4 or something like that is what it works out to. Depends on what you are doing. What the question is asking whether or not you would round. If it's number of kilometers, you'd probably round. You probably wouldn't leave 102 over 23 kilometers. So in other words, they don't always work out to nice whole numbers. Okay, what's different about F, or D, sorry? What's different about D? X is on the bottom. So this is one where I would take both bottoms and multiply them to the other side. So I end up with 7 times 100 equals 35x. And then what do? Divide both sides by 35, right? So x is 700 divided by 35, which is 20 exactly. I guarantee there will be a question using proportions on EQAO. And when I show you how to use them, you can actually set it up so x is never on the bottom, but that's up to you to be able to do that and understand it. So if you mess that up and x is on the bottom, it's still not too hard to solve. Okay, try this one. Anybody else get 12 again? Okay, good. And I'll let you do F on your own. I don't think there's anything different about F. These ones are a bit different. What does G mean? Again, I don't think this will really be on EQAO, but we're just covering a whole bunch of different things. Clear? It's a ratio, which is the same as a proportion. It's just written differently. So how would you solve this? You would turn it into a proportion. You can scale things up. This question won't work very well. The next one would. I can see that 15 is a third of 45, so 1 is a third of 3. Like, I can just figure that out. But for this one, I would do 4 over 8 equals x over 26. Actually, you can figure this one out as well, because this ratio is a half, so this one also has to be a half. So what does x have to equal? 13, half of 26. But you can also turn it into an equation, a proportion like this, and solve. And you get 4 times 26 divided by 8 equals x. And if you do that just to check on your calculator, sure enough, you get 13. Okay, I'm going to do the same thing here. Now we get to use a proportion. Ted eats 8 cookies in the same time Ned eats 3 cookies. If they continue at this same rate, how many cookies will Ted eat in the time that Ned eats 21? So this is how you set up a proportion. Everybody watch carefully. I always think of which question I'm asking first. So how many cookies will Ted eat? And that's my X. And off to the side, I'm going to make myself a note that this is Ted. How many will Ted eat when Ned eats 21? So this is Ned on the bottom. If Ted eats 8, so Ted is on top for both, that has to happen. And Ned eats 3. X is my question. How many will Ted eat when Ned eats 21? If Ted eats 8, when Ned eats 3. Do you see how that works? And if you always start with the question, X will always be on top. And I get X equals 8 times 21 over 3, which should work out to 56. And I'd like to see Ted eat 56 cookies, but maybe they're small. I don't know. Therefore, Ted can eat 56 cookies. So that's using a proportion. Start with your question. How many of this? That's your X. And make sure if you put Ted on top here and Ned on bottom, you put Ted on top here and Ned on bottom here. Okay, see if you can get this one at least set up. Okay, so I'm going to start again with the question, how many laps can Jim run? There's my X. If Tim runs 44, and how many of you had Jim on top and Tim on bottom for this proportion? Okay, good. And then you got to, and I think about this explicitly, whether you write it down on the side or not, I don't know, that's up to you, but you got to think about which one of these two things do I have on top? And if you just think about that, you're going to be fine. So Jim runs 3 when Tim runs 8. 3 times 44 divided by 8, which is 16.5. So Jim runs 16 and a half laps. So we'll take one of these up when we get to EQAO stuff. After you've done some practice on your own, we'll take one of these up or we'll do one together. Often they have a whole bunch of parts. So it's not like one proportion. You have to use like 3 or 4 proportions to solve some question. And sometimes you're comparing proportions to other proportions or comparing percentages to ratio or something like that. So they can be tricky. Okay, and finally, I think this is sort of the end. The last page here, we got a couple of examples to do. Now, these are rates and unit rates, but they're also proportion questions. You can solve them however you want. Sometimes it's useful to make a unit rate. Sometimes it's better to just use a proportion. Proportions will always work. Rates it's the same thing, though. So we're doing the same thing. So a person jogged 3 kilometers in 25 minutes. At this rate, how far could they jog in 40 minutes? So notice before it was Jim and Tim, and it was talking both distances. This one is talking distances compared to minutes. Different units, that's what makes it a rate. So the top here is x, how far. So this is a distance. Oh dear. So this is a distance on top, and this is time on bottom. So on the other side of the equation, I got to do distance on top and time on bottom. So I got 4.8. And that's kilometers. How long would it take this person to jog 20 kilometers? So how long to go 20 kilometers? So now my distance is on the bottom and my time is on top. I use the same one from the beginning though, but notice how my fraction flipped. In part A, I had 3 over 25, and in part B, I have 25 over 3. But because I started with my question, my x is always on top, and that makes my solving life really easy. And this one I'm going to round to 1 decimal place. Any questions so far? I'm going to show you one other little difference that we're going to do example 2 a little bit differently. Actually we have to, because it tells us to find a unit rate. What do you think it means by unit rate?
How much per?
Yeah, this is like when we did slope. When we did rates, we always found per 1 hour. So we've already done this. We just called it linear relations and slope, but it's the same exact idea. So this means in this case, per 1 day. So you probably know you can just divide by 10 to do that, but you could use a proportion as well. And I would say how much for 1 day if it's 6.45 for 10. So because I'm just multiplying by 1, that doesn't do anything. So this is $64.5 per day. And changing it to a unit rate means you don't need to use proportions, you still can. How much does he make for 25 days? So how much for 25 days if it's 64.5 for 1 day? But you probably know, don't you just multiply by 25? But look at how the proportion, the math, does the exact same thing. Solving a proportion is the same as your intuition that yes, if it's 64.50 for 1 day, 64.50, right? Then for 25 days, you just multiply by 25. But it works out the same mathematically. So that is $1,612.50. Okay, so I'm going to let you try example 3, and I'll put up the solutions in a moment. And then you can get started on the practice that's posted to the classroom as well.